name is Lisbeth, and today we're going to be going over this problem and how to tackle it. So I'm going to go ahead and read the problem. It says you wish to heat water to make coffee, because caffeine. How much heat in joules must be used to raise the temperature of 0.10 kilograms of water, which is around approximately 1 cup of water, from 19 degrees to 96 degrees Celsius, because the perfect brewing temperature is 96 degrees Celsius. And then it tells you to assume the specific heat is that of pure water, 4.18 joules over grams degrees Celsius. So let's go ahead and tackle one thing at a time. First of all, what is this asking us? So it says we wish to heat water. How much heat, right? So what do we know equals heat? So when you see heat, you should automatically think of Q, because Q is heat. So if you see heat, we know it should be Q. And then you should think about those Q equations. Let's see what else is given to us. So it says must be used to raise the temperature of, and they give us a mass, 0.180 kilograms of water. So if they give you mass, you should be thinking Q is equal to ms delta T. As long as they give you all the variables, we can definitely use that equation. So M is mass right here. So this is Q, and this is M. So now we're just missing S and delta T. Well, they give us two temperatures, right? So this could be delta T. And then this is S, right? Assume the specific heat. Wow, they said that pretty straightforward, right? So it's going to be our S. So now let's talk about everything. So we're solving for Q, so that's going to be our variable. Our mass is given in kilograms. It has to be in grams. So let's go ahead and convert that real quick. So we have 0.180 kilograms, and we know that in 1 kilogram there are 1,000 grams. So that would give me 180 grams of water. Alright, so that's going to be my value right here, 180 grams. We have our specific heat. Memorize this, by the way. Like, the specific heat of water is often not given to you in problems on quizzes or exams, just because we use water for everything. So if you haven't memorized that the specific heat of water is 4.18 joules over grams degrees Celsius, I would definitely just put that in your little archive in your brain. So I'm going to go ahead and write that. Joules, grams, degrees Celsius. So that's, if you notice, that's why this has to be in grams, because I need my grams to cancel eventually. So I'm just left with joules later. Let me try to get that. All right. And then we have delta T. So what exactly is delta T? Delta T is T final minus T initial. So we ended at 96 degrees Celsius. And this can stay in degrees Celsius, not Kelvin, because our unit is in degrees Celsius, and that way we can cancel that out. So we ended at 96 degrees Celsius, and we started at 19 degrees Celsius. So notice it says from 19 degrees Celsius, so that's going to be T1 or T initial, and then to 96, which would be T final. So now we can just simplify and plug those in. Notice that our grams are going to cancel, and so are our degrees Celsius. So that just leaves us with joules. So here we have 180 times 4.18 joules times 96 minus 99 is 77. So when you multiply all those through, you're going to get a very big number, 57,990 joules. So that's already given to us in joules. Luckily, we don't have to convert to kilojoules or anything. However, what about sig figs, right? Sig figs are super important. So here I see this has 3 sig figs, right? 1, 2, 3. This also has 1, 2, 3. The temperatures each have 2. So that means we can only have 2 sig figs, which means we're going to look at this guy, but we're going to actually be rounding this guy here, right? So I'm going to put in scientific notation just because it's a lot easier to notice your sig figs there. So my final answer would be 5.8, because that 9 is going to round that 7 up to an 8, times 10 to the 4th joules. So that's how much heat you need in order to heat up a cup of coffee, or heat up water to make a cup of coffee.